Okay, before we start this next standard, I need to look at a couple things. This standard is known as polynomials. That means you're going to see exponents that are higher than 2. So if you don't have, like this one here, don't write this down, but like, that's an example of a linear equation. There'd be just one answer, okay, because your x isn't to any power. This is an example of a quadratic equation. There's 2 answers. Now this standard, you're going to end up with stuff like this, okay? And now, as you know, you have a higher exponent, and you actually are going to be looking for 4 answers with that. But before we get into that and how to solve them, we need to know how to do some basic operations with exponents. So I want to look at a couple things. I want to write x to the second times x to the fourth, x to the fifth divided by x to the second. And then I've got x to the power of 3 raised to the power of 2. So let's look at how this works. So the factor x to the second means x is a factor twice, and then x to the fourth means it's a factor 4 more times. So how many times is x a factor? Well, it's equal to 6, so x to the 6th. So you notice how just because we were multiplying, that doesn't mean we multiply the powers, we actually end up adding those. Okay, now x to the fifth divided by x to the second. So in the numerator, x is a factor 5 times over. And in the denominator, it's a factor twice over. And then when I have common factors in the numerator to denominator, they actually end up canceling. Because when I divide and multiply by the same thing, it just cancels, giving me x to the third. So again, here, I didn't actually divide the powers, I ended up subtracting them. Okay, now, x to the third power raised to the second. Now let's look at the second power. That means x to the third is going to be a factor twice. Then x to the third means just x is a factor 3 times, and then x is a factor 3 more times. So that gives me x to the power of 6. Okay? Okay, so as you can see, what I could have just done is multiplied those powers, and yeah. So we have that means there's a time when we add the powers, there's going to be a time when we subtract the powers, and there are going to be times when we multiply the powers. So we're going to take these expressions and we're going to simplify the exponents. So let's look at this first one here. Okay, your most efficient way is going to make these 2 little boxes. And on the next packet, there's going to be a third box in between them, but for now, we'll just go with 2. Now, I kind of like, when I'm dealing with exponents, I kind of like to have a numerator and a denominator. That's just my preferred method. So all these, there is no fraction, so that means everything's in the numerator. So what are my bases? You have a base 3, a base x, and a base y. That means all these little things are exponents. Okay, now what I'm going to do is figure out the powers that are going to go on these bases. So I have a base 3. In the parentheses, it's to the first power, but then it's raised to the second power. So I need to take 1 times 2, and that's 2. Okay, now the x's. Now keep in mind there's 2 different x variables, okay, but I only write it just once. So this x is to the second, but it's raised to the second, so 2 times 2 is 4, so I'm going to put a little 4. And I put a comma because there's another x, and its power's to the 3. Okay, now I got to decide what I should do with the 4 and the 3. They're both in the numerator. Okay, they're both on top, so if they're both on the same side, we're just going to add them. It's like I have 4 x's here and 3 more here. So that gives me x to the power of 7. That's a 7th power. Okay, now as far as y's go, we have 2 of those as well. This is to the first, but it's in a quantity that's all raised to the second, so 1 times 2 is 2, and then we have a 4 right there. So again, they're both in the numerator, so I'm going to go ahead and add those together, and that gives me a power of 6. Okay, so I got 3 to the second, x to the 7th, and y to the 6th. Now the other box is just for simplifying the numerical bases. So this 3 to the second, 3 times 3 is 9, And then we can't simplify x to the 7th because that's a variable base. And then the same goes with y. That's a variable base. So there we have it. Okay, my next problem, same thing. I'm going to make these two boxes here. And again, I like to use fractions, and that's going to serve me well later. Okay, so here I don't appear to have anything in the denominator. It's all in the numerator. So my numerical bases are a 4 and a 2. We want to kind of put those together. My variable bases are a and b. So I write a just once and I write b just once. So again, the 4, we have a first power, but all that's raised to the third power, so 1 times 3 is 3. That's the only 4 you have. Now let's go look at our base 2. 1 times 2 is going to be 2. Now let's go look at our a's. We have 2 separate ones. So I have a second power. 2 times 3 is 6, comma. Then I have a third power. 3 times 2 is also 6. Now, both of those BA's are in the numerator. Okay, they're both in the numerator, so we just add those. 6 and 6 is going to be 12. Okay. Now for the b's, I got 1 times 3 is 3, and then 1 times 2 is 2. So both those b's are in the numerator, so 3 and 2, we're going to add those, and that's 5. So b is to the 5th power. Okay, now I simplify my numerical bases. 4 to the 3rd, that means 4 times 4 times 4, and that gives me a product of 64. And then 2 to the 2nd, 2 times itself is 2. Or no, 4. 2 times 2 is 4. Times a to the 12th times b to the 5th. Now, these two numerical bases, 64 and 4, those need to be multiplied together because it says 64 times 4, so I just take 64 times 4, and that's going to be 256. So the final answer is 256 times a to the 12th power times b to the 5th. Okay, and I'm going to keep moving on. Okay, this time I can actually see where my numerator, by the way, if you have two fractions, we're just going to extend it. That's going to be an algebra trick we use quite often. Okay, now my numerical bases are 2 and 3. And I also have a variable base of x, variable base of y. Now on bottom you just have more x's and more y's. Well, I only want to write the variable base just one time. Okay, that's silly to put x twice or y twice. Okay, so I've got a 2 to the 1st power, and that's not in a parentheses, so it's just to the 1st power. That's 2, by the way. And 3 is to the 1st, but that's in a parentheses. That's all being raised to the power of 3, so 1 times 3 is 3. Now, oh lordy, look at the x's. I got 4 different x's. I have a power of 3, not in a parentheses, so I write it, a comma. Then I go look at my next x. 1 times 3 is 3, another 3. X to the 1st, that's not in a parentheses, so that's just going to be a 1st power. And then I have a 2nd power. Now what in the heck do? I got to combine the powers. So I have 3, 3, 1, and 2. Okay, now these first two are in the numerator, and then the other two are in the denominator. Okay, so what I do is I add, but as soon as I get into one that's in the denominator, I'm going to start minusing, and I'm not going to stop. Okay, so I add the numerator and then start subtracting when I get to the denominator. So 3 plus 3 is 6, minus 1 is 4, minus 2 is 2. Okay, so that x is going to be actually to the power of, wait a second, 3 plus 3, that's a 3. That's really embarrassing. Okay, so it's to the 3rd power. Okay, now let's look at the y. So I have a 3rd power. I can't believe I don't deserve to be a math teacher for not messing that up. Okay, y, 1 times 3 is 3. Then I have a y to the 2nd and a y to the 1st. Now that parentheses does not cover that bottom, so that's just a 1st. You don't raise it, okay? So kind of like that one, I have a 3, a 3, a 2, and a 1. So the y to the 3rd came from the numerator, and so did that. Then I went to the denominator, so I'm going to add subtract, and subtract. Okay, so that's 6 minus 2 is 4, minus 1 is 3. Okay, so that is to the third power. Another way you can think of it is, okay, I have 3y's here and 3y's here, so that gives me 6y's on top. But they cancel with the y's that are on the bottom. So if I have a 2 and a 1, that's going to be 3. So if I have 6y's on top and 3 on bottom, that's going to leave me with 3 on top. Okay, it's another way you can think about that. Okay, so I got 2 to the first, that's 2. And then 3 to the third, 3 times 3 times 3 is 27. And then times x to the third times y to the third. And then we need to multiply 27 and 2, and that ends up 54. Okay, 54 times x to the third times y to the third. Okay, so the next one, make your 2 boxes. So my numerical bases, I have a 2, and then on bottom I have 4 and 5. So we got to remember to put those on bottom because they are in the denominator. For variables, I have m and n, but I don't want to repeat the letters on bottom. Okay, I'll deal with them all in the same place. So let's look at 2. All this is in parentheses, so 1 times 2 is 2. Now if you look at the m's, I have an m, another m there. So I've got 2 times 2 is 4. That's to the first, but it's all raised to the second, so 1 times 2 is 2. 2 times 2 is 4. So I got to figure out what I'm going to do with 4, 2, and 4. That came from the numerator. That came from the numerator. And then this one here came from the denominator. Okay, so denominator. So I add the numerators and then subtract the denominators. So that's 6 minus 4 is 2. So that m is to the second power. Okay, now the n, I got 3 of those. 1 times 2 is 2. 3 times 2 is 6. Then 1 times 2 is 2. So I got to figure out what I'm going to do with 2, 6, and 2. So that n is in the numerator. That n is in the numerator. And then that n went to the denominator. So I need to add the numerators and start minusing when I get to things that are in the denominator, because those are really just canceling out the top. So it gives me 6. So that n is to the power of 6. Okay, now the 4 to the first, 1 times 2 is 2. And then the 5, 1 times 2 is also 2. Okay, so I have 2 to the second, that equals 4, and then the m to the second and the n to the sixth just remain the same. Now bottom, 4 to the second is going to be 16, and then 5 to the second is 25. Okay, now I need to multiply 16 by 25. 16 times 25 is going to be 400. Okay, if you leave your answer like that, that's fine, but you can also reduce 4 and 400 into 1 over 100 if you want to just impress me. Some of you might not care, but that's fine. You can leave your answer like that. If that just confuses you, that reducing, that's fine. Okay, now we get into some much quicker ones. I kind of started off with hard ones, and then I'm going to go to these ones. So we got the numerator. The only base you got to worry about is y. There are no numerical bases, and I have a 3 and a 7. So 3 and 7, they're both in the numerator, so we add those, gives me 10. Okay, y to the 10th, you can't simplify. There's your answer. Okay, next problem. The only base is going to be y. And I'm going to be taking 2 times 7, which is 14. Okay, well, now that that's 14, I pretty much can't do anything with that. That's your answer. I don't care where you circle your answer. Just tell me what it is. Okay, so let's underline. So my numerator, I got 5 times 8 as the bases, as the numbers, and then x here. Okay, so 5 to the first, 1 times 4 is 4. 8 is just to the first because that's not in a parentheses. It's not raised to any power, so it's just the first. Then the x, 3 times 4 is 12, and then I have a 4. So 12 and 4. Those are both in the numerator, so I just add them together, and that's 16. Okay, now I need to do something in this second box. So 5 to the 4th, 5 times 5 times 5 times 5 gives you a product of 625. 8 to the 1st is 8, and then x to the 16th is going to remain that. Okay, now I need to take 625 multiplied by 8, and that's 5,000. Okay, 5,000 times x to the 16th is the answer to that problem. Okay, here's my next one. So that's my whole numerator there. I don't really have anything in the denominator. So my bases are 3 and -2, and then I have a variable base of x. So 3. 1 times 2 is 2. 1 times 2 is 2. Now I got two different x's, so 3 times 2 is 6, and then 4 times 2 is 8. Okay, so I got 6 and 8. Figure out what to do. They're both on top in the numerator together, so it's like I have 6 x's and then 8 more on the same side. That's 14. So x is to the 14th power. Okay, so 3 to the 2nd power is 9, and then -2 times -2 is 4. And then we got the x to the 14th power. So 9 times 6 is 36. 36 times x to the power of 14. Okay, let's keep on rolling. Next problem. Okay, so my only base here is 8. Well, I got lots of 8s. I got a 12th power 8, a 3rd, a 7, and a 2. So obviously I need to do some math with those exponents since it's all the same base. So these came from the numerator and then these came from the denominator. So I'm going to add the numerators and then start minusing on the denominator. That equals 6. Okay, so 8 is to the 6th. Okay, now I need to figure out what 8 to the 6th is, and that's going to be 262,144. Okay. Okay, my next problem. You see the fractions there for us, so I already know here's my numerator, here's my denominator. So I've got a base 4 in the numerator, a base 2 in the denominator. I've got a base a in the numerator, and then a base b, which is in the denominator. Okay, so 4, so 1 times 3 is 3, and then a, 3 times 3 is 9. 2, all this is in parentheses, so all of it needs to be raised to the power of 3. So 1 times 3 is 3, 2 times 3 is 6. Okay, now 4 to the 3rd is 64. It's not 12. You do that, you're kicked out of the class. A to the 9th, 2 to the 3rd, 2 times 2 times 2, that's 8, and then b to the 6th. Now look at your 64 and 8. You can reduce those, okay? You can divide those both by 8. So if I divide that by 8, that's 8, and that would be 1, okay? So 8 times a to the 9th over 1 times b to the 6th, or just b to the 6th. Because anything times 1 is just itself, no matter if it's a letter or not. Okay, now your fraction, all that is 1. So on the top, I got a 3 and an 8. Now for letters, I got M on top. Now there's also an M on bottom, but I just want to have it on top. Then there's an N that we don't have on top, but we do need to put on the denominator, okay? So 3 is to the 1st, so it's just to the 1st. I got two M's. We got 4 times 3 makes 12, and then we got a 5th here. So I got to figure out what I'm going to do with the 12 and the 5. Okay, that's a numerator, that's a denominator, so we need to subtract. So that's 7, okay, so that is to the 7th power. Okay, 8 to the 1st, it's not in a parentheses, so we don't raise it to any power other than the 1st. Now the N, 2 times 3 is 6, okay, so 3 to the 1st is 3. M to the 7th, and then 8 to the 1st is 8, and then N to the 6th. Now 3 eighths can't be reduced, so that's my answer. Okay, so next, numerical bases, I got a base 3 on top, a base 5 on bottom. For variables, I've got an x on top. There's also x on bottom, but we'll just have it take the top. And the same with the y. Okay? The bottom is just repeat variables, so I'm good on just having it on top. Okay, so 3. 1 times 3 is 3. Now the x's, I seem to have 3 of those. So 3 times 3 is 9. 4 times 2 is 8. And then 2 times 3 is 6. So I need to find out what I'm going to do with 9, 8, and 6. So that x comes from the numerator. That x comes from the numerator. And that x comes down the denominator. So we add and minus. That ends up giving me 11. So that's to the power of 11. Okay, now the y. 1 times 3 is 3. 2 times 2 is 4. Then I have a y down here in a parentheses, so 1 times 2 is 2. Okay, so 3, 4, and 2. So that comes from the numerator. That's in the numerator. That's in the denominator. It's numerator, numerator, denominator. So I'd add those, and I'm at 7. Then I subtract whatever's on bottom. So that's going to be 5. So y is to the 5th. Okay, now 3 to the 3rd, that's 27. Oh yeah, I forgot about the 5. 1 times 2 is 2. Okay, so that's 25. And then we got x to the 11th times y to the 5th. Now 27 25ths, that can't be reduced. That's going to be my answer. It's an improper fraction, but I don't care. Just leave it improper. Okay, then my next one. Remember, that is one whole fraction. So in the numerator, I got a numerical base of 8, a numerical base of 3. Now for variables, I have a numerical base x, a numerical base of y, and on bottom we just have more x's and more y's. Okay, so 8 to the 1st, not in a parentheses, so we don't raise it. It'll stay 8 to the 1st, which I think we know is 8. Okay, then the x, I got a 1st. But then there's another x, that's a 4th, but that's in a parentheses, so we need to raise it to the 4th power. So 4 times, actually cross this out. I don't want to get to that yet because you're going to get a negative power. That's for another packet. Okay, so big fraction. So on top I got 3 times x. Now 1 is a worthless base because 1 to the anything power is just 1. So if I have things up here already, I'm just going to ignore the 1. Then I've got a 2, but I've already written down the x, so that's good. So 3, 1 times 2 is 2. There's 2 x's. I got to take 3 times 2, and that's 6. 3. So I got to figure out what I'm going to do with 6 and 3. So that's numerator, denominator, minus. 6 minus 3 is 3. Now 2, 1 times 2 is 2. So 3 to the 2nd is 9, 2 to the 2nd is 4, and then times x to the 3rd. 9/4 can't be reduced. It is improper, but we're just going to leave it. Okay, so that's part 1 of simplifying exponential expressions. It's actually kind of boring, but